Ready? Polly wants a cracker. Let's go. Alright. So, what are we doing? Where's the asymptote? What are we worried about? So since it's going to infinity, we're talking about horizontal, right? Let's double check. Is there horizontal? Yes, there is. This one, again, they're the same power, right?
Yeah.
So the coefficient is 1 over 1, but it's negative. So it's going to go towards the horizontal asymptote is at -1. Okay? That means at -1, we have this horizontal asymptote. As we go to infinity, the last problem we chose 10 and 100, negative, right? So if we chose 10 and 100 again, let's do that. But I'm going to also take us up a notch. So let's just check it out. So here's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Right? So if we talk about f of 10, right? Then what is 10 squared? 100. Okay? So that'd be -100, right? And then what is 10 squared?
100.
100 minus 9. 91, right? That makes sense? So what is that? How many times? Ooh, really? Oh, that's good. Yeah, we'll see. We'll see. We'll see. Oh, I don't like that. Oh well, it is what it is. All right, so what is that? That's -1 and 8, right, or 9 left over 91, right? So it's a little bit more than -1. Does that make sense?
Yeah.
So that means that it's right here. It's really, really close. Right? So let's look at f of 100. Hopefully I'm doing it right. Let's see. So what is 100 squared?
Oh my, 1,000.
Close.
What is it?
10,000. We have 4 zeros. And it's negative, right? Now what's 100 squared? 10,000 again, but minus 9. So what is minus 9 from 10,000?
91.
9,991. Right? Okay, so that is equal to -1 and 9 left over 9,991. So that's really, really, really far or closer? Is that closer? Is that bigger? No, that's smaller. Oh, that's a lot closer to, so that's like really close to -1. Like really, really close. But they're kind of farther apart. You're going, I can't tell what's going on here. I can, but you might not be able to. So let's plug in a much better number. And I've noticed in these problems, the best number to plug in is 0. Okay, I noticed it on the last one, but we didn't get it on film. So if I plug in a 0, right? F of 0. What happens at 0? Well, that's 0, right? Okay? And this is still negative out in front. Oh, that's not good. That's really not good. What just happened? Because if I plug in a 0, it's going to go to 0.
It can't pass the asymptote, right? Or it can.
Well, there's another asymptote at 3 and at 9. 3 and negative 3. So at 3 there's an asymptote, and at negative 3 there's an asymptote. Alright? And so something's going to happen. Now, as we get close to 3, what happens? So that's the problem right there. What's going to happen at 3 is it blows up. So we got to look at what happens at 4. Because what's happening over here, inside these two asymptotes, something else is happening. We don't care. We want to know what's happening way out here. So we want to see if this thing dives down, which it should, right? We got to look at 4, right? One more than your vertical asymptotes. Because why is the vertical asymptotes at 3 and 3? And that's because, remember, this is a perfect square. So 3 times 3 is 9, right? But they subtract to be 0. That's why there's no x in the middle of your polynomial. Or, you know what I'm saying? So this is square root of 9, 3 and 3. So you got your perfect square problem, right? So having that, we're going to have to plug in f of 4 in this case because of the vertical asymptotes. Okay? So when we look at f of 4, what happens? Well, 4 squared is what? 16, right?
Yes.
And that's negative 16. Now, sorry. If I plug in 4 again, that's 16 minus 9. What's 16 minus 9? 7? Yeah.
7.
You're right. Sorry. Making sure we were doing this in pre-algebra and they were getting things wrong. I just want to double check. Alright, so can I break that down? No. So how many times is 7 going to 16?
Once.
Twice.
Twice.
Why?
Negative 2, right?
Same.
And 2 left over to 7, right?
I was saying you add.
So 14 to 16 is 2. Now you see what's happening here? Now it's going down to 2. So see how this changed directions real quick, right around 3? So after 3, it's gonna come from negative infinity, right, at the vertical asymptote. But as we're going to infinity, the limit is still going to be what the horizontal asymptote is. Okay? So you have to be careful the numbers you plug in. Because if those numbers are in between your vertical asymptotes, you're going to get a weird problem. See, this would look like this, and we know it can't go across that asymptote, so something's wrong. Does that make sense?
Yeah, we done.
I guess so. Are we done? Come on, we have 15 minutes.
Why?
Let's go! Let's go!